Hello Year 12 and welcome to our third video here for differential equations. Today we're looking at separable differential equations and solving these, finding a general and perhaps a particular solution to them. Now these separable differential equations that we're going to solve are going to be first order differential equations, and I'm going to be able to express them in the form of y prime equals some function of x multiplied by some other function of y, like the product of those two things. Now the way we're going to solve them is by dividing both sides by that function of y. So all the y's are on the left, including the derivative, and all the x's are on the right. Then essentially what I do is integrate both sides with respect to x, and by use of the chain rule, the dx's sort of cancel out and end up with the integral to y on the left and the integral dx on the right. That'll give me a general solution with an arbitrary constant. To find a particular solution, I'll need some sort of known or initial conditions to substitute in, usually an x and a y, to substitute in. Now there is one other thing to watch out for here, is that if my function of y is equal to 0 for some value of y, if some value of a makes my function of y equal to 0, then I would be making an error by dividing by 0. Right? And that's how we separate them, by dividing by 0. So first of all, we have to look for any values of y that will make the function of y equal to 0. And in that case, that will make the derivative equal to 0. And in that case, I take that out as a constant solution. Right? I look at that one first, I hold that off to the side, and I treat that as a separate case. And that way I avoid the problems with dividing by 0. So here's an example. I've got this separable differential equation. I'm asked to find particular solutions. So there is my differential equation, y prime equals negative x y squared. You'll see the font is fairly small now, and that's because there's a fair bit of work in this to try to fit it on the screen. So first of all, we can see that if y equals 0, then my function of y will be equal to 0, and I can't divide by 0. So we're going to look at that first. Y equals 0 is one of the solutions to this. Okay. Now, taking that aside, right, for all other values of y, I'm going to divide both sides by y squared. And now you can see I've got all my y's on the left, all my x's on the right. Integrate both sides. Now, you've got to do the same thing to both sides. I'm integrating both sides with respect to x, but my dx is going to cancel out a little bit there, and I'm left with the integral of 1 over y squared to y equals the integral of negative x dx. Now if you like, that's y to the negative 1. That's y to the negative 2, and I integrate that, and I get negative y to the negative 1. I've written it this way here. And the integral of, or the negative integral of x dx is negative half x squared plus some constant. And that is my general solution. I haven't made y the subject. There's a little bit of work to do that. Not very necessary at this stage. We weren't asked to find a general solution, just the particular ones. Okay, so we'll wait for the time being to make y the subject. So here we are, our first particular solution. From a general solution here, now I'm going to let x equal 1 and y equal 1/2. Substituting those things in, I get negative 1 over 1/2 is negative 1/2 of 1 squared plus some constant. Right, dividing by a fraction, multiplying by its reciprocal. So I get negative 2 equals negative half plus some constant. That means that my constant is negative 1.5 or negative 3 over 2. So in this case, the particular solution to y prime equals negative x y squared that passes through the point 1.5, 1 1/2, is y equals, well, in that case the constant will be -3/2, so we're going to substitute into our general solution. So -1/y equals -half x squared minus 3/2. Still a bit scrappy here at this stage, still a bit scrappy. So what I'm going to do is divide both sides by -1, and you can see again I've made a little typo. That shouldn't be a -3, that should be a +3. So watch out there, there's a little mistake. That should be a +3 because I've taken a negative out of everything. And we have the same denominator, so I've combined those. Right, so now it's x squared plus 3, x squared plus 3, sorry for the mistake. And now I'm going to take the reciprocal of both sides, and I get y equals 2/x squared plus 3. Bit scrappy. So that's my first particular solution. My second particular solution is when x equals 2 and y equals 0. We need to go back here to the beginning, very close to the beginning. We know that y equals 0 is a solution. So if one of my points, if one of my coordinates for that point is 0, then the solution there is y equals 0. Doesn't matter about the x in this case. If my y coordinate is 0, then the solution here is y equals 0. That's it. That's all we do for that one. So they were my two particular solutions using separable differential equations. So a differential equation that can be written in this form, y prime is some function of x multiplied by some function of y. We look for any constant solutions, divide both sides by that function of y, and then we don't differentiate both sides, we integrate both sides. There's another mistake. Bit scrappy. Anyway, that's it for separable differential equations. Our next video are two other types of separable differential equations. And after that we move into applications. But that's the big key skill that we're going to learn in this topic, is dealing with separable differential equations. Rightio, I hope you enjoyed. If there's any questions, let me know. I'll see you in class.